All right, here we go. Unit 5, Lesson 1, the extreme value theorem. We're going to be talking about today mins and maxes, the plural Latin term for these, extrema, meaning extreme values. But we're going to break those up into two different types. We've mostly so far talked about relative extrema. Those are the ones where I ask you to find the relative mins and maxes of a function, and you found maximums of functions by finding where your function has a horizontal tangent line, and the tangent line slope, the derivative switches from positive to negative, and you found minimums by finding where the slope of the tangent line, the derivative of a function, switches from negative to positive. But what we're going to also be talking about today is we need to be very careful when someone asks you for a min and a max, whether or not they're talking about a relative max or an absolute max or min. And what I mean by that is, if I ask what is the maximum value of this function here, well, yes, you'll find this relative minimum, but that's not this relative maximum, but that's not the absolute maximum of the function. Absolute means the highest you ever reach, and that would just be this endpoint here, right? And so let's look at this function on the right. This is just f of x. There's really no calculus here yet. We're just talking about vocabulary. So 1, let's look for where the relative mins are. So where are the places that are like low points compared to the points around them? Well, that's going to happen at -3. And at 2. So relative mins at -3 and 2. Second, let's talk about relative maxes. Well, relative maxes means when did you hit a high point relative to the points around you, so locally, and that's going to be at -1, at x equals -1. Let's talk about an absolute minimum. And there would be an absolute minimum, just 1, because absolute means the lowest point you ever reach of this function. And so this is going to be at x equals -6. And when we get to finally an absolute max, this function has none. It has no absolute max because this function has no endpoints. It goes on forever. And so when we talk about absolute and relative mins and maxes, we just need to be careful in terms of what is the domain that this function takes place on. What is the domain that this function takes place on? So let's move this to calculus land. I think we actually don't need that extra example. Let's say I ask you to find the absolute extrema of the function f of x equals 3 times x to the 2/3 power minus 2x on the interval -1 to 8. And here is the key idea. I don't know what this function looks like, but if I do two things, if I find everywhere that my function has a horizontal tangent line, right? These are potential turnaround points. These are potential turnaround points because they represent places where my function might have stopped going one way and started going another. So I need to test all of those points. I'm going to test this one, and this one. I also need to test the actual endpoints. If I do both of those things, I will be able to find the absolute max and min. Because either the endpoints are the maxes and the mins, or one of my turnaround points represents the maxes and the mins. So one of these two things is going to be true. So as long as I test the endpoints and I test these what we call critical points, then I will have found the absolute maximum. So if I ask you to find an absolute extrema, or all of the absolute extrema, I'm asking you to do two things. First, to take the derivative if you don't already have it. The first derivative here, using just the power rule, 2/3 times 3 would be 2, x to the 2/3 minus 1, negative 1/3, minus 2. I want to know, when do I hit these horizontal tangent lines? When is my function turning around? So I want to know when this is equal to 0. When is 0 equal to 2x to the negative 1/3 minus 2? When is 2 equal to 2x to the negative 1/3? When is 1 equal to x to the negative 1/3? Cube both sides, or however you want to see solving this, raise both sides to the negative third power. 1 to any power is just going to be 1. So we have x equals 1 here as a critical value. We have a critical value at x equals 1. So 1 could either be, right, this 1 could either be just a relative min or max, or it could be the absolute max, but we don't know. What we need to do is we must compare the relative extrema to the endpoints. And for this, we go back to the original function. We need to plug in 3 values. We need to plug in 1. So we need to find f of 1. So we plug in 1. We'd have 3 times 1 to the 2/3 minus 2 times 1. That's just 3 minus 2. That equals 1. But like I said, maybe this is the actual min or max, or maybe it is just a relative and the function is actually higher at the endpoints. So what we also need to do, we need to plug in the endpoints from this interval. We need to plug in f of negative 1, and we need to plug in f of 8. So we plug in negative 1, 3 times negative 1 to the 2/3 minus 2 times negative 1. Now this one takes a little bit more thinking. So negative 1 to the 2/3 is going to be the cube root of negative 1 squared. Okay, so that's going to be the cube root of 1. That's just equal to 1. Okay, so that's still 1. So we have here 3, negative 2 times negative 1 plus 2, we'll have 5. And we'll have f of 8 is 3 times 8 to the 2/3 minus 2 times 8. And so what we'll have there is we'll need 8 to the 2/3. That's the cube root of 8 squared, the cube root of 64. That is just equal to, not 8, that's 4. So the 8 to the 2/3 is 4. So we have 3 times 4 is 12 minus 16. We're going to have here negative 4. And so if I look at these, again, I've got the graph here, so we're going to see it in a second. If I look at these, I know these are the only possible values for my relative extremes, because either it's one of the endpoints or it's one of my turnaround points. So I just have to pick the highest and the lowest. We have the absolute min is going to be at negative 4, is going to be at 8, negative 4. I know my absolute max is going to be at negative 1, 5. And so let's see what this looks like. Let's see what this looks like on the actual graph, confirm that it is correct. We said the absolute min, again, on the interval. We were told on the interval from negative 1 to positive 8, that's our interval. We correctly identified the absolute min is at 8, negative 4. And we also correctly identified that the absolute max is at negative 1, 5. And as you can see, the other critical point that we tested, here, we found 1, 1. We found out that that was just a relative extrema. We didn't do a sign chart, but we could have done one. It's not an absolute. But this is a really good place. You can see my point here of why you have to test it. Imagine this function actually looked like this. Well, then that would have potentially been your absolute max on that interval. So the key point for today, to find absolute extrema, you have to test f of x at two places, or at two types of locations. One, at what we call critical points. And I like to refer to those as turnaround points. They're points where the first derivative is equal to 0, and 2, you have to test at the end points. That is when you are finding absolute extrema. So don't lose sight of the fact that if I ask you for a relative max, I'm still just looking for you to make a sign chart and figure that out.